In this video, we're going to talk about recursion. Recursion is a problem-solving technique that happens to be very old and that could be applied to many problems, in particularly problems that have some sort of repetition or loop in their solution. The definition of a recursive method in Java or in any other programming language is simply a method or a function or subroutine that calls itself. So I'll show you a couple of examples later on, but you're going to see that in the body of the method, there is a call to the method itself, and that's what it makes it recursive. Because of this, we're creating repetition. So we're trying to apply the same solution, the same solving technique to a particular problem until the problem is solved. This is actually part of the divide and conquer techniques that we have seen many times in computer science. And what that means is we take a large problem and we try to divide it into smaller problems. So recursion works in a sense in a similar way. We're given a problem that is sort of complicated or complex, and we don't know the answer to that particular problem, but we know the answer to a problem that is similar to that one but much, much smaller. So the question is, can I reduce the size of the problem that I'm giving to a size where I know the answer? Okay, so that's basically what recursion is. So let me start with a very famous example. If you go into any website discussing recursion or any textbook discussing recursion, chances are that you're going to see that a way to explain recursion is by providing a solution to the problem of calculating the factorial of a given number n. Okay, so if you're not familiar with what factorial is, and I'm pretty sure most of you are, this is the formula for factorial. So given a positive integer n, the factorial of n is n times n minus 1 times n minus 2 times n minus 3, and eventually, because we're subtracting 1, we're going to get to 3, 2, and then 1. And it's understood that the factorial of 1 is 1. So, as I said, we can solve this problem using a loop, and actually the right solution for this type of problem will be a loop because we'll be more efficient, but we will get into that later on. But let's assume that we want to use recursion. So the problem is, can I calculate what the factorial of 5 is? And there are many ways, many approaches to solve this particular question, but here's a particular and interesting one. I could tell you that the factorial of 5, based on the formula that I'm given, is 5 times the factorial of 4. And that could be my answer. And that is the correct answer. Probably not the answer that we want, because what we're expecting is a numerical value. In other words, when I ask the question, what is the factorial of 5, we expect then a number, not something that says, oh, it's 5 times the factorial of 4. Because in reality, I haven't solved the problem. I just restructured the solution by saying, oh, the solution is based on calculating the factorial of 4. And when I do the factorial of 4, then it's going to be the same thing. That's 4 times the factorial of 3. 3 is 3 times the factorial of 2. 2 is 2 times the factorial of 1. And then I'm going to get to factorial of 1, which I happen to know the answer. And when I got to that, then I can see everything that we just wrote and then work myself backwards and saying, I know what the answer to factorial of 1 is. It's 1. Having said that, then now I know the answer to this particular problem, and therefore I know the answer to this problem. So the factorial of 2 is 2 times 1, which happens to be 2. Now I know the answer to this problem, factorial of 2. And when I know that answer, then I can calculate the answer to factorial of 3, which happens to be 3 times 2, which is 6. And again, that gives me the answer to factorial of 3. Once I know that, I can calculate the answer of factorial of 4, which is 4 times 6, which is equal to 24. And once I know that, then I know the answer to this, which happens to be 24, right? And then I can say, oh, the factorial of 5 is 5 times 24, which happens to be 120. So the answer to the original problem, what is the factorial of 5, is 120. So let's analyze what we did. What we did was to first express the problem in terms of a problem that is similar but smaller. So factorial of 5 can be expressed in terms of factorial of 4. Factorial of 3 can be expressed in terms of factorial of 2. And the assumption is that calculating the factorial of 4 is more difficult than calculating factorial of 3, and that's more difficult than calculating factorial of 2, or in other words, that factorial of 1 is easier to calculate than factorial of 2. So once I get to something that I know the answer to, then I can work myself backwards. Also notice what I'm doing. What the technique of recursion does is to also reduce the size of the problem. I went from factorial of 5, right, down to factorial of 4, then factorial of 3, then factorial of 2, and eventually factorial of 1, which is small enough or simple enough that I know the answer to, which is 1. So the technique in recursion says, take a problem, see if you can find a problem similar to the one that is given, but is less complex. And most of the time, less complex, less complicated means a smaller in size. So here I started with factorial of 5, and I reduced the problem to factorial of 1. The next step in recursion is, well, once you know that, then work yourself backwards. But the beauty of recursion is that if we're writing a program, then the computer will take care of working backwards and figuring out what the answer is going to be. So let's formalize now the answer to the problem. So here we can see both solutions. So this is a typical method in Java that returns an integer, which is the factorial given an n. So if I plug in here the value 5, I expect this to give me 120. So what is the problem that I know how to solve? Factorial of 1. So I'm going to say here, well, if n is 1, that means the question you're asking is, what is the value of factorial of 1? I know the answer, so I can immediately return 1. But if I don't know the answer, what is that I'm going to do? I'm going to express then the solution based on a smaller problem, a smaller in size, like factorial of 4, 3, 2, or 1. So how do I do that? I said, well, I need to multiply, right, something, n, times a factorial of n minus 1. So it's here that if n is 4, then the factorial is factorial of 3. If n is 2, then the factorial is n minus 1, which is 1. So that's exactly what I'm doing here, all right? And if you type a program and run this thing, you're going to see that this actually works. Again, keep in mind that this is a common example for recursion. It's not the best example, it's not the most efficient example for recursion, but it's one that is easy to understand. Now, let's formalize the parts that we have in the recursion method. There are 3 parts: the base case, the reduction step, and the recursive call. So let's go back to our solution. So remember, we were reducing the size of the problem until we got to a problem which is similar, related to the original one, but smaller in size, much less complex, that I know the answer to. This is what we call the base case, right? The base case is a problem small enough that I know how to solve. So what is that? Well, when n is equal to 1, then I know the answer, return simply 1. Now, reduction step means that I'm going to make the problem smaller and smaller so that I can get to my base case. How do we make the problem smaller and smaller in this particular case? Well, simply by subtracting n minus 1. That's what the reduction step is. Now, most of the time, the reduction step is part of the recursive call. The recursive call means that within the body of the method, which is what I have highlighted, I have to call the method itself, so it makes it recursive. So here I'm calling factorial, and I'm reducing the size of the problem because I'm subtracting 1 at a time. So basically what I'm doing in my code is trying to replicate this, is factorial of n times factorial of n minus 1, factorial of the new n times factorial of the new n minus 1, and so on and so forth. That is exactly what is happening in this example. So again, base case is the problem that is related, that is similar to the original one, but much smaller in size, much less complex, and of which I know the answer. And then I need to reduce the original size of the problem that I'm given until I get to the best case. And of course, I need at one point inside the method make a recursive call. So typically, a recursive method is going to have a statement that is a conditional. It's either an if or an if else. Why is that? Well, because you need to test whether or not you arrive to the base case. And if you do, then you know the answer. And if you don't, then there is something else that you need to do. In a different video, I'm going to show you 2 other examples of how to use recursion and how to write recursive methods in Java. Now, not every problem should be solved recursively because recursion has potentially some serious disadvantages. One serious disadvantage is that it consumes memory. What does it mean? Well, let's go back to this code in here. Assume that now n is large enough, like n is 44. So that means that you're going to make at least 44 recursive calls. Every time that we make a recursive call, then we need to make copies of this in memory. These addresses that are being allocated to the method, to the parameters, to the local variables, to the calculations, etc., etc., etc. So to do something which is fairly simple, calculate the factorial of 40, means that we're making 40 copies of these methods. That consumes a lot of memory. The other thing is, and it's not in this example, but in many examples that you find in textbooks, for example, the Fibonacci series, you can do excessive recalculations. And if you take a look at the Fibonacci series, you can Google this and find a solution. You're going to see that sometimes some of the series, the numbers of the series, are recalculated more than twice, sometimes even 3 times. So, well, that's a waste of time. We should only calculate the third number in the series of Fibonacci and somehow store it and make use of it. So I just want to make you aware that not every problem should be solved using recursion. So having said that, what are good examples of recursive problems? Well, the Towers of Hanoi problem. If you're not familiar with this, you can Google Towers of Hanoi and it will explain the problem to you, which happens to be a very, very old problem, and a recursive solution. Granted, you can solve the problem without using recursion, but you will see that the recursive solution is much more elegant. Then there are other problems which are very, very complex to solve. The 8 queens problem, which means can you place 8 queens on a chessboard without attacking each other? Fractals, which happens to be exclusively recursive. And backtracking, which is used in computer science and in many of our daily activities. Think about backtracking is when we work backwards. So in the example that I just showed you in here, when I said, let me work backwards, this is what we call backtracking. So I'm going to use some information to arrive to a new piece of information. I'm going to use the answer to factorial of 1 so I can calculate factorial of 2, and then the answer to that so I can calculate the factorial of 3, so on and so forth. But there are many, many applications of backtracking in computer science. And in real life, think, for example, the problem of walking through a real maze. So what happens when you hit a dead end on the maze? Then you go back, right? So you're backtracking and try to make a different turn. So instead of going to the right, you go to the left. But examples of recursion, which are typically found in textbooks, are, as I said, the Fibonacci, the power function, exponential function, and factorial function. Again, I encourage to see some of these good problems, Google them, and find the solutions and take a look at the code and the discussion of the problem. And I encourage you to watch the next video, which is called Factorial Examples, in which we're going to discuss 2 examples of good problems using recursion.